Good morning. Here I have come with this topic. Today's topic is neutrino. Can you see? Neutrino. It is a particle. In the study of particle physics, you will get this particle. Okay? Neutrino. Plural is neutrinos. Okay? And these are the points which I am going to discuss: properties, detection, neutrino oscillation, astrophysical neutrinos, neutrinos in cosmology, and at last there is the applications. So neutrinos, I think you might have heard name of this particle neutrino. Earlier, this particle was assumed to be massless. But later it was discovered that neutrinos are also having mass. Okay. So what is the amount of mass of a neutrino particle? It is very small. It is very, very small than the mass of an electron. If you divide the mass of an electron by 500,000, okay, then that mass will be equal to the mass of one neutrino particle. So at present, what is known? Neutrino is mass. Neutrinos are having mass. Okay, these are not massless. Right. And what about charge? Neutrinos have no charge. These are chargeless particles. You know, electrons are having charges. It is negative charge. Protons carry positive charge. Okay, and neutrons, neutrino and neutrons are different. Okay, neutrinos and neutrons are different. In the nucleus, along with protons, you will get neutrons, but neutrinos are different than neutrons. So neutrinos, these are having masses and they have no electric charge. They are chargeless. And one more thing, neutrinos are of three types or are of three flavors. Okay, those are electron neutrino, mu1 neutrino, and tau neutrino. Electron neutrino, mu1 neutrino, and tau neutrino. Three types of neutrinos are there. Neutrino particles are there. So what is electron neutrino? The neutrinos which interact only with electrons. The neutrino particles which interact only with electrons are called electron neutrino. Electron neutrinos, okay? They interact, means neutrinos interact with only weak nuclear force with the electrons. Only weak nuclear force. There is no question of electromagnetic force, because these are chargeless particles. There is no effect of strong nuclear force on neutrinos. And of course, there must be the effect of force of gravitation on neutrinos, because these are having masses. Since these are having masses, so there must be effect of gravity on neutrino particles. So what are electron neutrinos? Neutrino particles which interact only with electrons are called electron neutrinos. Similarly, mu1 neutrinos are there. Means neutrino particles which interact only with muons via or through weak nuclear force are called mu1 neutrinos. And at last, what is there? That is tau neutrino. Means neutrinos which interact only with tau particles through weak nuclear force are called tau neutrinos. So these are what? These are the properties of neutrinos. This is the first point. Next comes detection. How neutrino particles are detected. So for the detection of neutrino particles or neutrinos, neutrino telescopes are there. neutrino telescopes are there, scintillation detectors are there, then water or ice Cherenkov detectors are also there. Okay, so those instruments are used for the detection of neutrino particles. One more thing I have missed to say, I have missed to mention here, that neutrinos can travel through or can propagate through space, as well as neutrino particles can propagate through matter also. Okay, neutrino particles can propagate through matter also, and I have already said that mass of a neutrino particle is equal to mass of an electron divided by 500,000. Okay, so mass of a neutrino particle is very, very, very small as compared to the mass of an electron, right? And all the three types of neutrinos are having the same mass, right? I mentioned that three types of neutrinos are there: electron neutrino, muon neutrino, and tau neutrino. Next comes point number 3, neutrino oscillation. Yes, neutrino oscillation, this is a property of neutrino particles. This property you won't observe for all types of fundamental particles. But for neutrinos, this property will find neutrino oscillation. Here, what is the meaning of neutrino oscillation? Means when neutrinos are propagating from one place to another, whether through space or whether through matter, there is a change in the flavor of neutrino particles. Means while traveling, say electron neutrinos can change themselves into muon neutrinos. Say muon neutrinos are traveling, while traveling they can change themselves into tau neutrinos. So during the travel from one place to another, there is a change in the flavors, or there is a change in the types of the neutrinos. So that property is called oscillation. Okay, means they are oscillating between between different flavors, right? So that is one of the properties of neutrino particles. So that was point number 3. Next comes point number 4, astrophysical neutrinos. Astrophysical neutrinos means they are not special neutrinos. Astrophysical neutrinos means neutrino particles or neutrinos which are found in the sun, in other stars, in supernovae, okay, in microwave background radiation, where cosmic rays are interacting with atmosphere. So in those cases, neutrino particles are found. So those are called astrophysical neutrinos. Astrophysical neutrinos. Okay, they don't have some other properties, same properties. 3 types of neutrinos are there, not more than 3 types of neutrinos are available wherever you go. Whether it is sun or whether it is any other star, whether any galaxy, wherever you go, you will find only 3 types of neutrinos. Okay. So those are called astrophysical neutrinos. Neutrinos found in stars, supernovae, etc. Next comes point number 5, neutrinos in cosmology. Neutrinos in cosmology in the early universe, means when the Big Bang occurred. Okay, in the early universe, neutrinos were there. So, neutrinos played a crucial role in the early universe. So, by studying neutrinos, we can, it is hoped by the scientists that by studying neutrino particles in detail, okay, we can, will be able to know the structure and formation of the universe at its early stage, means during the Big Bang, right? So that's why neutrino particles are of great interest for the physicists. they are trying to study in detail, though still, okay, not each and everything has been found about neutrino particles. Researches are going on, okay, and so that's why the point number 5 is neutrinos in cosmology. That means in the study of cosmology, neutrino particles are studied in great detail, right? Last point is applications. Applications mean in the area of astrophysics, in the area of cosmology, neutrino particles are studied, and that is the application. To know cosmology in detail, or to get the full knowledge of cosmology, to get the full knowledge of astrophysics, okay, knowledge of neutrino particles are essential. So that is one kind of application of neutrino particles in the study of cosmology and astrophysics. Again, researchers or the physicists are trying to devise technologies which is called neutrino based communication technology. Okay, this is in research stage at present. Okay, neutrino based communication technology. So this was all about neutrino particles. Okay, so this is the end of this lecture. Thank you for watching this video.